Hey everyone, my name is Nick Wong, and I'm a software engineer here at Paubox. And today I'll be talking about how Paubox's email API can support contact tracing and test result delivery applications and workflows. Let's jump right into it. So today I wanted to share about two public health topics that I'm sure we've all heard about due to COVID-19. The first is contact tracing, used to notify people about potential exposure to COVID. And the second is surveillance testing, used to monitor and slow community spread. So here, these are two different strategies used to fight COVID, but both can use Paubox's seamless and secure email API to save lives. And today, I'll show you folks how. So contact tracing, the objective of contact tracing is to work with an infected individual to identify and provide support to potentially infected contacts. So this is done to prevent further transmission of the disease. This process starts with a confirmed case of COVID-19. Then the local health department is notified and immediately dispatches a contact tracer to interview the infected individual. That contact tracer will counsel the individual into isolation and will attempt to notify all close contacts of that infected individual. Over the next 14 days, there will be follow-ups via phone and email, and where the contact tracer will provide further instructions and further support to those who are isolating. And the CDC defines a close contact as someone who was within 6 feet of an infected individual for at least 15 minutes, starting from 2 days before illness onset. So the Lancet, a peer-reviewed medical journal, found that contact tracing strategies are only effective if they are completed and done in less than 3 days. So contact tracing is a multifaceted system that relies on speed and efficiency of scarce resources in order to be effective. But unfortunately, across the US, from Hawaii to Austin, Texas, and even to New York, we're seeing headlines in the news like these. Secure communication in healthcare is simply too slow to support effective contact tracing efforts, and this needs to change immediately. So I've learned that effective contact tracing strategies require contact tracers on the phone, reaching out and calling infected individuals on what can be extremely sensitive topics. Tracers must be adept at addressing the situation and communicating in an appropriate and compassionate manner. So by removing the fax machines and automating what can be automated, like email notifications and transmittance of test results between systems, we can allow contact tracers to prioritize what's most efficient, what's most effective, and save lives. The next strategy I wanted to discuss here is asymptomatic surveillance testing. And the objective here is to monitor the spread and intensity of COVID across the United States, further investigate and understand disease severity, and keep local communities safe by controlling asymptomatic community spread. So we're seeing higher educational institutions across the US, ranging from both large public institutions to small private schools, implementing surveillance testing strategies as an integral component of their campus recovery initiatives. So whether you're a student in the dorms or an employee working regularly on campus, everyone here is mandated to participate when it comes to keeping their campus communities safe. And as a student of UC Berkeley, this is how my school is implementing this strategy. So as you can see on the table, depending on the category that you're in, you're either required or recommended to test once or twice a week to keep thousands of students and employees safe. So from college campuses across the nation to even the MBA's bubble, frequent asymptomatic testing will help prevent the spread of COVID-19. But the current technical setup for many of these programs use a secure portal, and this has revealed challenges for both program administrators as well as the end user. So for administrators, there are additional administrative costs as well as the added security risks. So learning and training employees to use new software, as well as keeping login credentials safe, are some of those costs. There are unnecessary steps to sending messages via an online portal, and there are ultimately lower engagement rates with those messages. So from a user standpoint, they must go through the process of creating and verifying an account just to read a simple message. And often these users have a very frustrating mobile experience doing so. So as a result, users who may be asymptomatic take longer to read their messages. And in a pandemic where time is of the essence, these extra steps can become a public health threat. So clearly, there are flaws in these systems that we already have in place, even in the most distinguished of institutions. So the question becomes, how can we create and innovate on current low-cost, efficient, and secure systems that can scale and protect the health and also the privacy of those in our community? So whether that's notifications or follow-up instructions from contact tracers, or even reading and storing test result data from electronic health records, or sending hundreds of thousands of test results back to patients in a seamless and secure manner, Paubox's email API can be the foundation that scales any contact tracing and test result delivery data flows. So now a little bit more on Paubox's email API. The API is a lightweight, HITRUST CSF certified email used by developers and IT professionals. It can seamlessly integrate with any modern technical stack with SDK support in 7 different programming languages. It's optimized for email delivery, allowing users to enable DKIM authentication protocols. And Paubox even signs a business associate agreement for all Paubox email API customers. The main value add, or one of the main value adds we're creating here, is basically no portals. We want to increase engagement rates and decrease time for individuals to access their messages. Ultimately, we're creating frictionless communication. So this diagram here is a sample flow of how Paubox's email API can integrate into your existing technical stack as a standalone microservice or script. So when run, the email API can transmit sensitive PHI, or protected health information, from your existing data store and send that information to patients by performing a simple HTTPS request. So this is a seamless, secure, and a lightweight approach to basically sending sensitive data from electronic health records or existing databases to patients and clients. And this same architecture can be generalized to transmit secure communications with other systems. So essentially, the email API can allow you to create scripts and microservices that pull in PHI or other sensitive information from your existing data store and send that information over via email to clients or even other healthcare systems. So the possibilities are really endless. Other ways you can leverage this email API could be sending appointment or prescription reminders, sending data from an EHR to patients, sending receipts or billing reminders, or even promotions regarding new services or products, or even new policy changes to your organization. So these are just a few of the endless possibilities that can empower developers and builders and IT professionals who use this API. So I'll now go ahead and I'll share a little technical demonstration about how you can get started with Paubox's email API. I'll be writing a quick microservice in Python, and that fetches PHI from a secure data store, and we'll use the Paubox email API to send that information to clients. All right, so referencing this diagram from a few slides ago, I'm now going to demonstrate how we can write a small script that leverages the Paubox email API to send secure messages to our patients. For the sake of the exercise, I'll be using a Google Sheets CSV as my existing secure data store, and I'll walk everyone through writing some logic that'll extract that data from the CSV, pass it to the email API, and the email API will send that data and transmit that data securely to our patients. So let's get right into it. So this is on my web browser. I have a few things open. The first thing is my CSV file. I just wanted to walk you folks through it. The first thing in the CSV file is a unique email then a name associated to that unique email, and then a test result associated with that unique email. So whether it's true on the test or false, negative on the test, I've indicated a basic profile here. The next window I have open is the Paubox Email API dashboard. As you can see, I have just verified my domain with Paubox, and since I'm here, I can go ahead and create a new API key for this demonstration. So I'm going to copy and paste this into my development environment for safekeeping that we will use in a little bit. Awesome. Now the third thing I have open is the Paubox Python SDK. So all SDKs for the Paubox API live on GitHub and can be accessed by our website at paubox.com. So let's get started, and I'll walk everyone through how we can get started really quickly. So we already have verified our email with Paubox and created an account. We just generated an API key. So now let's create this config file. It looks like an environment variable file. So going back to my development environment, as you can see on the left here, I have only two files. So the first file here is the data store that downloaded as a CSV file. And the second is the Python script that we will write that I'll get to in a little bit. But let's first make that config file that I just talked about. So I'm going to paste this in there, take my API key that I saved, pop it right there. And looks like I will swap out my endpoint name right here. That's care share, just like that. I'm going to give this a save, config.cfg, pop it right in there. Amazing. So now let's return back, wrong way, back to the instructions. We're going to need to run some install commands, all right? So I can run pip install config. And I have already installed this as well as the Paubox Python package. So there's no more installation needed there. So why don't we jump down all the way down here and get some of the starter code. All right, so I'm going to pop this into demo.py. And as you can see here, first two lines look like import statements. 4, 5, 6 looks like we're going to be pulling some environment variables using the config package to pull some environment variables from our newly made config.cfg. Line 8 looks like we're instantiating an instance of the API client using those API keys and the hosts that we passed in from our environment variable. And below it, we have some recipients from subject, content, and it looks like those are the components needed to send a piece of mail, which is done on lines 13 and 14. As you can see, a new mail object is created, and on line 14, that mail object is sent. Lines 15, 16, and 17 simply look like some print statements saying that things have gone well or things have not gone well. So why don't we first start with creating a small function that will do this, kind of generalize this code for a little bit for us. So let's start with definition, defining a send function with recipients, subject, and some content. And this will make our email. Let's add a colon there. Make sure to give that some space, just like that. Amazing. So with this, we won't need the recipients because this will be passed in as a parameter, as well as subject, and as well as content. We can also set the from variable as maybe a global variable. Let's call it sender. And I'm going to say all emails are sent from this email. And since we're here, let's change this. We don't need this anymore. And we're going to need to pass this in. Here, sender. Awesome. And we're going to do one more environment variable. Let's call it recipients. And what recipients will be is an empty dictionary that will contain all of the emails and data associated with the CSV file. Awesome. So now let's give that a save. Now let's jump into reading CSV. So for reading a CSV, we're going to need some Python packages. So import CSV. We're going to do with open. This is called data store.csv, second parameter R. I'm going to read this as emails. Cool. Now we're going to create a reader, which is csv.reader emails. It's going to read through our CSV. Now let's iterate through it. Let's extract some data. So for each row in our CSV, let's say that the first thing we want is the email, which is in row 0, I believe. Yep. Oh, 0. Second thing we want is the name, row 1. And the third thing that we want is the test result. So let's just say result. How about that? Row 2. Awesome. So now we've extracted those things from the CSV. And now let's input it into our local dictionary if it does not currently exist within it. So quick test, quick if statement. If email not in recipients, then let's add it. Recipients with the primary key of being an email, and the value will be a tuple of a name and a result. Awesome. This looks pretty good to me. And of course, good practice is to close your reader after you are done with it. Close. Nice. So just to recap what we've done so far is we've created a send function that generalized the starter code from Paubox and takes in recipients, subject, and some content. And we have read our CSV file down below. Amazing. So now let's create a function that will generate basically two messages depending on whether the patient has tested positive or negative based on the CSV account. So let's say, let's generate email, generate message. This message is going to take an email, so whatever is going to be passed in from the local dictionary. So the recipient is going to be read from our local dictionary. Recipients is recipients.getEmail. Awesome. Now let's deconstruct this a little further. Name is recipient's first thing in the tuple, right? Second thing is the test result. And this is the second thing inside of the tuple. Amazing. And we can define a subject for our message that we generate. Let's just say something fun like Paubox email API test result. Ah! Test result. And let's make it a little dynamic here. For name. Awesome. Cool. So now since we have test result here, we can make a simple if statement. If the test result is equal to true, then why don't we send, hey, your test result has come back positive. So here I have a predefined message that I wrote. Test result for name came back positive. Oh no. And we're going to hit return the tuple, subject, and content. Now else, if the test result is false, this is good. So we will send another message that I have pre-made. Test result for name came back negative. Also, return tuple, subject, content. Amazing. So now what this did is basically you pass it in an email, and we will look into our local dictionary, get that email, see if that email has a positive or negative test result associated with it, and return to you the right email that we want to send back. Awesome. So now with these three components done, with the send function defined, generate message function defined, and with the CSV read, we can go ahead and send emails at scale now. So now let's iterate through all of the emails. For each email in our recipients.keys, because all of the keys in our dictionary are unique emails. Let's extract some information. So the email that we want to send is generate message with that email. So now it's going to generate the appropriate message to send. Now the subject is going to be that email. We're going to decompose this email, this tuple. subject, content, second part of that tuple that's returned from generate message. And now let's send. So now we can do send. Now it takes in a recipient, right? So our recipient is an email with the inside of an array. The second thing that we want to send is a subject, and the third thing we want to send is content. So now let's give this a save. All right, and let's demonstrate the next into terminal. So let's clear this, and let's see if this works. Python demo.py. Amazing. So we got some print statements back from our send function that basically say that service is all good. Looks like provides us a tracking ID, and with the email API, Paubox's email API exposes an endpoint where you can pass it a tracking ID and find the status of the email. But it looks like we've gotten some HTTP status codes of 200. So very nice, chef's kiss. And looks like, check out my email. And here we go. Test result for Nico Wong came back negative. Amazing. Now let's check if this was indeed what was stored in our CSV. Nice. So right, Nick Wong, nick@paubox.com, associated Nico Wong, and it was indeed negative. Awesome. So that was a quick demonstration using Paubox's email API to send secure messages to clients. Thank you. Awesome. Thank you.
Man, Nick, great job. Let's see. We got a question that came through here, so I'm just going to read it. Thanks, Nick, for the coding example. From a security standpoint, we would need to ensure the data is secured in transit from the database to the service and the service to Paubox. Is that correct?
Yes. So you would essentially, this script would live on your server, so that's going to be on the same side, and Paubox handles all of the sending from your system to clients, or sending from your system to Paubox and Paubox to your clients.
Terrific. I think we've got about 5 more minutes to go. I'm monitoring the Q&A section. I don't see anything else coming up just yet. But I know you and I, Nick, have been on the lookout for hackathons, healthcare hackathons around the country. And I think you found a couple coming up in the near future. Is that correct?
Yeah, we would love for Paubox to basically kind of sponsor an award at some of these different hackathons at local universities across the nation. So pretty soon I'll reach out to CalHacks, which is the local UC Berkeley hackathon. I know I've attended TreeHacks once before, and they've had specific awards for students based on whether or not you can use a certain company's API. So I would love to see some student-generated ideas that leverage the Paubox email API in the future.